Hello and welcome to my final project, which is the Arduino Smart Car. My name is Adel Merzoug, and this presentation is for my class CINF 467, which is Tech-Based Community Support, under our professor Michael Lizinski at UAlbany in the spring session. A brief overview of the project. So the Arduino Smart Car project is a robotic project that involves building a small car-like robot capable of autonomous or remote control movement. The project typically involves integrating various sensors such as ultrasonic sensor for obstacle avoidance and line following sensor for navigation, with all a deep robot control board. The goal of the project is to create a versatile and programmable platform for experimenting with robotics and automation. The smart car can be programmed to perform tasks like following line on the ground, avoiding obstacles, or even mapping its surroundings. It is a hands-on project that combines electronics, programming, and mechanical design, which can be ideal for learning experience for students. As a project overview, the smart car is a small, as you can see here. It's the size of my both hands together. It's a programmable robot built on chassis. It's in the bottom down here. Wheels, motors, various sensors. We have ultrasonic, line sensor. It is controlled by a deep robot control board. This is it right here, which acts like a brain of the car, receiving inputs from different sensors and sending a command to the motor to navigate its environment. The features and functionality for the project, besides the fact that this car equipped with sensors that gives the capabilities to achieve some tasks, it is also worth mentioning that the project illustrates a few features that can be seen, such as remote controlling. So the car can be also controlled manually using remote control or a graphic user interface, GUI, from a laptop or an Android smartphone or a tablet, and make sure it's an Android anyways. And we may have to use the deep application. Another feature is programming capabilities. So the user can program the smart car using the Arduino IDE to perform various tasks and behaviors. When it comes to the hardware component, so the kit came with all the parts and the components, the screws necessary for the smart car to build. But the parts that are worth mentioning regarding to this presentations are, we have a deep board. They call it a deep robot control board. It is fully compatible with Arduino Uno or Arduino One. DC direct current motor for driving the wheels, which is down here. We have two of them. The line following sensors, it is down here at the bottom for tracking the lines on the ground. Chassis to hold the components together. This is the whole black thing in the bottom that holds the wheels, the batteries, and mostly the board also. Wheels, of course, it's a car. We have four wheels. A power source, which is rechargeable batteries. They're in the bottom down here. Jumper wires. There's 4 wires in here between sensors on the board and the motors. A light tracking module, which is right in the front. And LED matrix, it's in the back. And OLED display, which is on the top. Sometimes it gives the information about what kind of sensors are working and how the car is behaving. For the software, first of all, we have to talk about what is Arduino. So Arduino is an open source electronics platform based on easy to use hardware and software. The Arduino Smart Car uses the Arduino Integrated Development Environment IDE, which support programming in C++ for my case. Some of them they use Python. So the IDE software is user-friendly, enabling the writing and uploading the code directly to the Arduino, or in my case, a deep board. The key libraries also, such as a servo for motor controls and new ping for ultrasonic distance measurement, are also used to simplify the coding process. Right here we have a block diagram showing how the hardware and the software components are integrated. So as a start, before we start the car, when we hit any direction, we have to use the Wi-Fi. We use the Wi-Fi control mobile app, transferring the data through the Wi-Fi, and then from there the Wi-Fi moves the signal to the Arduino for the car, and whatever's happening in the servo or whatever happening in the deep board, you have to check the signal. If car is moving left, right, backward, forward, and depend on that, the car will do the if or else logic, and then transfer the data to the deep board control, and then move the car to wherever the users wanted to move, and that'll be it for the moving the car. And if you want to do something else, we have to go over the chain again, and we start again for giving another control by using the Wi-Fi. When it comes to implementation, so the steps taken to build the car were straightforward by following the download the files from the PDF files that were provided by the website. The challenges that I faced was regarding the implementation of this software, or how to get the car move the way that I wanted to move. Like, for example, I want it to go left, it does not go left, or just go right. It's just, sometimes doesn't even want to move. Even my first challenge was when I assembled the car itself. Actually, when I have it to work, one wheel was going forward, the other one was going backward. So there's the kind of challenges that I faced in my project. So for the features, so the Arduino Smart Car has the three pivotal features: obstacle avoidance, line following, and light following. For obstacle avoidance, it uses an ultrasonic module to detect barriers, allowing the car to steer clear automatically. The preset distance for the clearance was 20 centimeters, but it is customizable according to the user. Following the line involved in line tracking module to trace the following line. Light following enables the car to move forward light source using the light tracking module, which is ideal for navigating in a variety of, in the darkness, or in a variety of lighting. So this functionality enhances the car ability to autonomously navigate complex environment. So as a result, after countless attempts to get the car controlled by the graphic user interface, I finally get it to work. The obstacle avoidance feature worked fine, but with the line following feature, I am still having a hard time to figure out why it's not working accordingly. As a conclusion, so me personally, I love robotics and enjoy seeing robots that can follow commands or operate automatically. It's fascinating to watch robots perform tasks like following a line, moving an obstacle moving from point A to point B. For instance, some grocery stores use robots for cleaning and disinfecting. Robots navigating crops field in agriculture to check for crop abnormalities, and companies like Amazon use this in the warehouse and order fulfillment. Working my own robotic project, assembling a smart car was particularly integrating for me. I made sure every part was correctly attached and connected. However, the real challenge began when I tried to get the car respond to commands. It was exciting at first, but I had a little bit of complication toward the IDE using the Arduino software. But to say the truth, it was exciting as an educational to tweak the programming and rearrange the components to see if it could improve any performance. So this process was difficult and it took a lot of time, but finally getting to work right made all the effort worthwhile. From this project, I learned that even with a complete kit, like the one I bought from Amazon, from parts, from codes, from all the tools, there is still a lot to learn about how things works. It is important to keep experimenting with different steps and programming approaches. As technology evolves and continue, by looking at problems from various angles and continuously testing new ideas, we can find better solutions and keep improving our results. As acknowledgement, so I want to take this moment to thank our Professor Luzinski, Michael Luzinski, for giving me the opportunity to work on my project. I also appreciate my classmates, Josie, Rosdal, Reese Bowie, Demon Reed, and Eric Raymer for their help in the makerspace, which helped me make progress on my project. Additionally, I must thank all my family and their support, especially my wife, who was incredibly patient and allowed me to devote such a time as needed for my project. Well, I think that will be it. Thank you very much, and I wish luck to everyone, and see you soon. Bye.